Okay, so we just looked at a story where it's telling us that one positive number exceeds another by 4, and their product is 77. And then they ask us to find the numbers. Okay, so there's no fluff to this story, right? But they do tell us that we're dealing with two positive numbers because it says one positive number exceeds another. Agreed? So, we have the first positive number, and then we have a second positive number. And you know, this is the part that most people don't bother to write down. And sometimes, because they don't write it down, they don't get the rest of the story right. So I'm going to recommend that you write this stuff down. So, one positive number, so I'm just going to say the first positive number, exceeds. What does that mean, exceeds? Yeah, it's bigger than, right? So I have one number, it's bigger than another one by 4. So if it's bigger than it by 4, what operation are they talking about? They're talking about addition. So you know they're going to be adding 4. The question is, what are they adding 4 to? Good, another number. So do I know what this second number is? Nope, I don't. And I know most of you say, call it X. You know, I get tired of X's. I'm going to use S. S for second number. So, S plus 4. Got it? Okay, and then it says their product. What does it mean by the product? Yeah, it means to multiply them. So I'm going to take the S plus 4 and I'm going to multiply it by S. And when I do that, it says that the product is 77. And then it wants us to find the numbers, doesn't it? Awesome. Okay, so what do you think you're going to do? Well, it looks like it's factored, right? But does it equal 0? Nope. So is it factored correctly? Nope. So what are we going to do? Yeah, just like we did in that just a few moments ago, right? We're going to have to distribute this. So we distribute, we get S squared plus 4S equals 77. And then what can you do? Yeah, subtract the 77 over. And now that this is actually equal to 0 and the power is greater than 1, now we can factor it. And now we're going to see what the correct factoring is for this problem. Good? Okay, so I'll do some side work over here. By the way, I'm hoping you're getting the hang of factoring because there are going to be times that I may actually not show you how I factored it, right? I am going to assume that you're doing really well with your factoring steps. Okay, so we got to find all the combinations that multiply to a negative 77. And hopefully one of them adds to a positive 4. And that looks like the one, right? Okay. Which means S squared minus 7S plus 11S minus 77. We pair them up, right? Good. Take an S out of here and a positive 11 out of there, right? Did you catch that? Okay. So take an S out. We have S minus 7. Take a positive 11 out, right? Or divide by a positive 11 might be the better way to say that. And we have S minus 7. And now we know that the factoring looks like this. Which means back over here, I know that this is the real factoring problem that I'm supposed to work on for this problem. And then I get to set each of these parentheses equal to 0 and solve, right? How many answers are we getting? Yeah, 2, because this is a second degree polynomial, which means you're supposed to get 2 answers. And one of those answers is a negative 11 and the other one is a positive 7. With me? Okay, so now the question is this. Because this is a story, right? Are both answers acceptable? Like, I don't know. How do I know? This is why it's important to write this information down. We have the first, what kind of number? Yeah, the first positive number. Okay, and then we have a second positive number. So are both these answers allowed? Nope. This one, even though we did everything right, this one, not working for us. Why? Because it's not positive. This is the answer that's working for us, which means my second number is a positive 7 and my first number is a positive 11. Cool? Okay, hang in there. Got another story for us. Okay, so we just looked at a story that again really didn't have any fluff to it. It said the shorter leg of a right triangle is 21 feet less than the other leg. And it said find the length of the two legs if the hypotenuse is 39 feet. Now I don't know about you, but I'm a visual person. So me being visual, what do you think I'm going to do? I'm going to draw myself a picture. I like having pictures to go with stuff. And the one thing it told me was I'm dealing with a right triangle. Agreed? And it said the shorter leg, and it didn't really say where the shorter leg was, right? Okay, so that's our choice. So I'm just going to call this one the shorter leg. So it said the shorter leg is, well that means equals, the shorter leg is 21 feet less than the other leg. So 21 feet less than. What does that mean? Yeah, you're going to minus. Now, where's that 21 go? Before or after the minus sign? Remember, it's at 21 feet less than something else. Right? It goes at the end. And it's 21 feet less than the other leg, right? Well, here's the other leg. And yes, they're expecting you remember what the legs of the triangle represent. Those are just the two sides that make up the right angle. Okay, the other leg. Do I know what the other leg is? Nope. So, and no, I'm not using X. I can use L for leg, right? So this is L, and I'm making it a capital L. So this is L. And then it says, and the hypotenuse is 39 feet. So all these are in feet. And then it wants you to find the actual lengths of these legs of the triangle. So here's the deal. You're dealing with a right triangle, aren't you? Okay, get those brains in gear. Back to sophomore geometry. What goes along with a right triangle? There's a Greek guy who kind of came up with something that goes along with a right triangle. Yep, there you are. Pythagoreans Theorem. You remember Pythagoreans Theorem? Yep, some of you do because I'm hearing you. Pythagoreans Theorem says a squared plus b squared equals c squared. And which is the one, which variable do you have to remember and identify correctly? Good, the hypotenuse. And the hypotenuse is c. That's this guy, always. That's the hypotenuse. So yeah, they're expecting you remember your sophomore geometry days, right? Do we care which one's A and B? Nah, doesn't make a difference which one's A and B. Why? Because I'm adding them. And it doesn't matter the order in which I add. Cool? Okay, so here we go. We have A, which is one of these legs, and it doesn't matter which one, so I'm going to say L, and we have to square it, and then we have to add the other leg, which is L minus 21, and then we have to square it equals 39 squared. Cool? Okay. So this is clearly L squared plus. Yeah, you're going to have to distribute that, aren't you? So we're going to do some side work over here. L minus 21 times itself. So let's make certain that we all have this correct, because if this isn't correct, then we're up a creek, right? So I end up with L squared minus 42L plus 441. Cool? Okay, so that's going to take this place right here. L squared minus 42L plus 441 equals 39 squared. Okay, so on the left side, we combine like terms, don't we? So we end up with 2L squared minus 42L plus 441 equals, and now you got to square the 39, right? Okay, well, I know you got your calculators. I'm going to get mine just for the sake of time, because I don't want to waste our time. And that I got equals 1,521. And now what are we going to do? Yeah, because this is a power of 2, I'm going to have to factor to solve it correctly. But before you factor it, it must be equal to what? It must be equal to 0, which means you got to subtract that 1,521 to the other side, don't you? Okay, so when we subtract it over, what'd you get? Yeah, I got a negative 1,080 equals 0. Cool? Okay. So, time to factor, isn't it? Well, this looks lovely. What do we do first? Yeah, we're going to reduce this, aren't we? So when we reduce it, we're going to factor out a 2. We end up with L squared minus 21L minus 540 equals 0. And now I've got to find the combinations that multiply to 540 and at the same time, add to a negative 21. With me? Okay, so we got a little bit of work to do here. And you're like, well, how do I do this? Because, I mean, you know, there's a lot of numbers. I know there's a lot of numbers, but you still need to keep order. Don't go out of order, because if you go out of order, you're probably not going to find the combination. So we need to do, that's a 1 there, right? So 1 times negative 540 equals negative 540. And we're trying to come up with a 21. So we know 1 times 540 ain't going to do it. 2 times, well, that'll be what, 270? Yeah, that's not going to do it. 3. See what I mean? You kind of have to start going down the list. 3 times, 4 times, 5 times, but you can kind of start thinking, you're like, well, some of those numbers are too small. It's not going to work. So me personally, I think I would jump to 10. Remember, I'm still keeping order. My brain's going 1, 2, 3, 4. I think I'll start to 10, and that would be 10 times a negative 54, right? Which if I combine those gives me a 44, so I'm kind of getting closer. And then I would try, I don't know, does 11 go in there? What do you guys think? Yeah, I don't think so either. What about a 12? Yeah, 12 does go in. So let's see, what did you get? Yep, I got a 12 times a negative 45, or a negative 12 and a positive 45. So what does that give me? That gives me 33. I'm getting closer, right? Okay, so after 12, you think 13 goes in? Nah. 14, 15 might, because it ends in a 0, right? Okay, so 15, what'd you get? Times negative 36, or a negative 15 and a positive 36. Hey, I think that adds to 21. Awesome. Which combination? I need a negative 21. Yep, this one. Positive 15 and a negative 36. Which means we are going to have L squared plus 15L minus 36L minus 540. We're going to pair them up. So out of here I'm taking an L. Out of the second pair a negative. Yeah, negative 36, because we already know 36 goes into 540 evenly. You just found it. So let's keep working on our factoring. Minus 36. So we get a positive L here, and we get a positive 15 there, which tells me my factoring looks like this. The quantity of L minus 36 times the quantity of L plus 15. Cool? Okay, so yay, we factored it. So now let's see what this looks like. So we still have the 2 there. L minus 36 in one parenthesis, L plus 15 in the other parenthesis, equaling 0. And now everybody's got to get set to 0, right? Well, 2 equals 0. Well, that doesn't make any sense. So there goes that one. The other one is L minus 36 equals 0. So L is a positive 36. And over here, L plus 15 equals 0, which means L equals a negative 15. So we have 2 answers, right? Remember, we know we were supposed to end up with 2 answers because this is a power of 2. So I was supposed to end up with 2 answers, which makes sense why this one does cancel out, because if that one actually was an answer, then I did something wrong. Okay, now this is a story. I know it doesn't have any fluff, but I'm still dealing with a right triangle. So let me ask you something. Can the shorter leg be 36? Sure. I'm sorry, not the shorter leg. Could this other leg be 36? Good. Could the other leg be a negative 15? Yeah, that doesn't make any sense, right? Because it's the length of the leg. So we did everything correct, but can this number be an answer for the length of one of the sides of the triangle? Nope. So bye-bye, there it goes. So I know this leg is 36. 36 what? Feet. Good. And now the shorter leg, how do I find it? Yep, according to get to the shorter leg, we got to do 36 minus 21, which is 15 feet. Cool? Does this make sense? If you need to, rewind the video and rewatch this one. This one's a really good problem. It's got a lot going on, and a lot of it is stuff that we learned way back when. The only new stuff really is right here, when you're like, oh my gosh, I'm going to have to set this equal to 0 and factor because that power of 2 says to factor. Cool? Okay, hang in there. Got another one for you. Okay, so we just read through another story, and the story was talking about an electrician who needs to run a cable from the top of a 36-foot tower. So here's my tower. And so from the top of the 36-foot tower to a transmitter box, right, located 15 feet away from the base of the tower. And they want to know how long should this cable be. Well, they gave us a picture, which was very nice of them. Now here's the deal. There's fluff in this story, and they gave me a picture to go with this fluff. We need to back this picture down to like bare bone math basics. And you're like, what does that mean? You know, does this represent any kind of shape, any kind of object? Because if I can recognize an object, then I know how to deal with it. So what do you think? Some of you are going, well, it kind of looks like a triangle. I agree, it does look like a triangle. Now let me ask you a question. This tower, is this tower like, I mean, if it's going to stand, does it lean at all, or is it like straight, perfectly straight? Yeah, it needs to be perfectly straight, correct? Which means the tower needs to make a right angle to the ground, doesn't it? Which means we have a right triangle. And if that's a right triangle, what's the Greek guy we're supposed to think of? Pythagoreans Theorem. And what's his theorem? That's right. A squared plus B squared equals C squared. Cool? And which one of these three variables do we identify correctly? Yeah, C. Remember, C stands for the hypotenuse. And as a refresher, the hypotenuse is always opposite that 90-degree angle, in case you had forgotten that. Okay? Hopefully the last problem reminded you of it though. Okay, so which one of these is the hypotenuse? The cable. The cable's the hypotenuse. That's what I'm looking for. So, do I care which one of these two sides of the triangle is A or B? Nope, could care less. So I am going to say 15 squared plus 36 squared equals C squared. And C I'm leaving because C stands for cable, right? So now, yep, handy dandy calculators. I already know 15 squared is 225. We have to come up with 36 squared. What is 36 squared? Good, 1,296. And then we get to add these two guys together. Agreed? Oh yeah, I know you're working on your calculators like I am. Good? Okay, so now my question to you is this. I need to solve for C. How do I get rid of that square? Yeah, to get rid of a square, you got to do its opposite. And what's the opposite of a square? Good, a square root. Now remember, how many answers does this square tell me I'm supposed to get for C? I'm supposed to get 2 answers. So when I take the square root, one of my answers is going to be positive. And the other one? Yeah, the other one is negative. And you're like, how do you get a negative? Remember, let's just say if I wanted to do the square root of 9, what times itself is 9? Yeah, a positive 3 times a positive 3. But couldn't it be a negative 3 also? Because doesn't a negative 3 times a negative 3 still give me a positive 9? That's why you get 2 answers, one positive and one negative. So in this case, C will be equal to a negative 39, but C could also be equal to a positive 39. Good? Okay. Which one of those is the cable length? Can it be both of them? You're right. It can't be negative. We don't have any rulers with negative numbers or tape measures with negative numbers, right? By the way, if you do, I want it. So send it over. Okay. So this answer, even though we've done everything correct, is out of the picture. My cable length is 39 feet. The cable length is equal to 39 feet. And by the way, it's just a coincidence that these numbers are the same as the last problem, so don't get too excited like, oh, it's always these numbers. No, it just worked out that way. All right. Cool? Well, this was a much nicer Pythagorean theorem problem, wasn't it? Okay, stay tuned. Got another example. All right, so our next problem is talking about the cost for manufacturing X units of a certain product. And they told us that to find that cost, this is the function we're going to look at. Cool? Okay. And then it asks, by the way, before we go any further, I have a couple of variables here. I have this C of X and then I have this X. So you know it's always a good idea to write down what these represent. According to them, C of X represents the cost. And then X by itself represents the number of units. It's always a good idea to write that stuff down, okay? And then it asks us to find the number of units with a cost, or the number of units manufactured with a cost of $8,550. So when they ask us to find the number of units, what are we finding? Yeah, we're finding X. And they gave us $8,550. What did that represent? Yeah, that's the cost. So they're telling us, right? They're saying the cost is $8,550, and that's in dollars, which means this represents the C of X. So in other words, my equation is going to have a substitution in it, isn't it? Yeah, out goes the C of X, and in goes the 8,550. Cool? Okay, what are you going to do? Good, I heard you. Move the 8,550 to the other side. Why? Because you need it equal to 0. Why do you need it equal to 0? Because you're going to factor. What tells you to factor? The square on the x tells me to factor, right? The square on the x says factor, which means set it equal to 0, which means move this number to the other side. Cool? Okay, so handy dandy calculators, right? Because you know we're going to need them. All right, so moving this to the other side. And I know some of you are very quick on those calculators and you already have this number. I don't, but I'm getting there. Okay, so this is what I got. Did you get the same thing? All right. And now, isn't this lovely? To factor this, we're going to have to do the first number times the last number. And now we need to come up with the combination, don't we? And that combination needs to add to a negative 17, correct? Okay, time to work down our list. You know, 1 times whatever, 2, 3, 4, 5, all those numbers times whatever, you know, those aren't going to work very well. And you're like, well, what number would you start with? Well, let me think. I think I might start with, I'm working on it. Okay, so I'm going to start in the 20s, and I'm going to start with 28. And 28 times a negative 303. Well, that certainly isn't going to be a 17, but I'm moving closer. So I think I might try numbers in the 40s. So I would start with 42. And 42 does go in there. And this is the number I got. Well, it's certainly not 17, but it's getting closer, isn't it? Well, I think I might try numbers in the 60s then. And you're like, well, what would you try? Well, I'm going to start with 62 and then 64 and kind of go from there. I'm trying even numbers. Why? Because it ends in an even number. So more than likely an odd number is not going to work. Well, I didn't find anything in the 60s. So now I'm going to try the 70s. Okay, so I tried 72, 74, right? Okay, not finding anything that works there as well as I would like. Let's see. Sorry, my brain is thinking. So I found 84 times a negative 101. Wait a minute. I think that worked. That does. Because if I add those two numbers together, I get 17. There's my combination. Yay! So do you see how I tried that? I started in the 20s, and that distance was still 200 something. And then I said, well, let's go to the 40s, and that distance was still like 100 something, so we're getting closer. And nothing in the 60s worked. And then I went to the 80s, and I found something that worked. So we are going to take x squared, and we are going to do plus 84x minus 101x and minus 8,484. And then we get to pair them up. Again, the key to finding this middle combination is keeping order. Did you hear what I did? Start in the 20s, too much here. Went to the 40s, still too much. Tried the 60s, nothing happened. Tried the 80s and found it. Okay? All right, so x goes into here, and the second pair goes, negative 101. I already know 101 goes into 8,484 evenly because we just did the math here. So we have x plus 84 in that parenthesis. And gratefully over here we have the same thing. So we end up with these two parentheses. Cool? Which means back over here, 0 is going to equal this product. And now I can take each parenthesis and set it equal to 0. And when I do that, the first answer is 101 and the second answer is negative 84. Got it? All right, so both answers good? Yeah, no, I agree. Why not? Because we said X represents the number of units that they're manufacturing. Can they manufacture a negative amount of units? No, so there goes that one. Which means, yep, they're manufacturing 101 units to get a cost of $8,550. Cool? Awesome. Hang in there. Got one more problem. Let's look at this last one. We have a person who has a rectangular board that's 12 inches by 14 inches. So that's in the middle here. Got it? And around which she actually wants to put a uniform border of shells. Now, the picture they gave you is a lot nicer than the picture that I drew up here. Mine's not very uniform, but pretend it is, right? And you're like, what do they mean by uniform? It means that all the way around is the same width, which is why in this case they put X's here, because the distance from between the bottom and the border here is the same distance as between the sides, okay? And again, their picture looks a lot nicer than mine, so take a look at theirs. All right. If she has enough shells for a border whose area is 192 square inches, determine the width of that border. Now, notice they give us a very key piece of information. They said she has enough shells for the area of the border to be 192 square inches. So let me write that down. The border, sorry, how about we spell that correctly? I'm thinking the board inside. The border area is equal to 192 square inches. That's all of this in here. All of this here has an area of 192 square inches. And they actually want me to find that border width. What's going to be the width of that border in order for us to have 192 square inches? Well, I have a little bit of a challenge, because if I look at just the border, it's not a rectangle. It's kind of like a donut rectangle, right? If I take out this middle, it's kind of like a donut in the shape of a rectangle, but the middle is cut out. So I don't know how to find the area of something that looks like that. I know how to find the area of a rectangle, but I don't know how to find the area of like a little strip like this. Cool? All right. But we make a good point. We know how to find the area of a rectangle, correct? If I knew the area of this entire rectangle, then maybe that might work for us, yes? Okay, so let's check this out a second. Do you notice that in the middle, right, is a rectangular board that she has? Well, go with me here. The board area, how much is that going to be? Did you figure it out? Okay, I know some of you are on those calculators already. All right, so I got 168. Did you? So that's 168 square inches, which means this total rectangle area is good, 360 square inches. And I know some of you have been on the calculators, which is totally fine. Okay. So, notice what we just said. The total rectangle area. That means this length, and that means this width. If I multiply those together, that gives me 360 square inches. Are you with me? Okay, so do I know this length? Some of you say, kinda. I know at least from here to here is 14. That's true. So from here to here is 14. But remember, you have x on this side and x on this side, which means this length is going to be 14 plus 2x, because I have an x on each side. So if I take this x, add it to 14, and add it to another x, that would give me 14 plus 2x, wouldn't it? Good. Now, what about this width? You're like, well, I know this is 12. That's good. But remember, I have x down here and x here, which means, like, it's kind of the same thing. You're right, it is the same thing. It's going to be 12 plus 2x. Does that make sense? Okay. So, what are we multiplying together? I'm taking the length of 14 plus 2x, that's the length of this entire rectangle, and I'm multiplying it to the width of 12 plus 2x, which is the width of the entire rectangle, and that's going to equal the total area of 360, isn't it? All right, now, my recommendation is to pause the video, go back, and kind of listen to this again to make certain you understand where we're going. I cannot find the area of a donut, but if it's filled in, I can find the area. With me? Then, since I'm solving for x, x already represents the border. This will be, when I find my answers for x, I know what my border is. Cool? Okay, so we've got some multiplication to do. So we've got 14 times 12, which we already figured out was 168, plus, good, 28x, plus, good, 24x, plus 4x squared, equaling 360. Good? Okay. I know, you're like, the numbers are kind of big. I get it, but we can handle this. So I'm going to put the left side in descending order, and I'm also going to collect the two terms in the middle. I've got a 28x and a 24x, which looks like 52x plus 168 equals 360, right? Then what? Yeah, we're going to have to subtract the 360 to the other side. Well, I already know that. That's 192. So 4x squared plus the 52x minus 192 equals 0. Agreed? Okay. And now we have to factor. Remember, the whole reason we set it equal to 0 was because it's a second degree equation. And that second degree equation, that degree of 2, tells me I'm going to have to factor to solve this. But it's got to be set equal to 0 to solve it correctly. Cool? All right. I don't know about you, but I'm going to see if everything divides nicely by 4. So clearly the 4 does. I know 52 does. I just have to make sure 192 does. I got it. It did. Yay! So, I'm going to continue this over here. Factor out the 4, we get x squared plus 13x minus 48 equaling 0. Right? Okay, So I need some combinations for 48 that gives me 13. So let's talk. We're going to have, and I'm going to do my work over here. 1 times negative 48 gives me the negative 48, right? And now I've got to continue to factor that. So we know the 1, we know the 2. What's after 2? Good, 3. And 3 does go in there. Negative 16 or a negative 3 and a positive 6. Oops, think I found it. Right here. Negative 3 and positive 16, right? So I'm just going to cut straight to the chase, and I'm going to, you put these 2 in and factor, but I'm cutting straight to the chase. This factors 2. Which means, well, 4 doesn't equal 0, so there goes that. X plus 16 equals 0, which means x is a negative 16. It can't be that, right? Because borders can't be negative. And x minus 3 equals 0, which means, and there it is, right? My border has to be a positive number, so this uniform border is 3 inches. All the way around that piece of border. The board she put in the middle that she wants to put seashells around, that uniform border is going to be 3 inches all the way around. Cool? Okay, as always, when you need to, go back and rewind each story, so to speak. Listen to it again to make certain you understand it. And you guys have fun with solving by factoring, especially these applications, and I'll catch you on the flip side.